In this video, we'll learn what is capacitance. And capacitance is the ability to store and release electric charge and energy. Capacitor is a device used to store electric charge and electric energy. So the simple capacitor is the parallel plate capacitor. So parallel plate capacitor consists of two parallel plates. So with the area A and distance between the separation distance is D. When we connect this capacitor to the battery, so it started storing the charge and energy. The capacitance C of the capacitor is defined as a ratio of maximum charge Q that can be stored in capacitor to apply the voltage V across its plates. So in our equation, we use that the capacitance is the function only of the geometry and what material fills the space between the plates of this capacitor. So in our case, the material is vacuum. That's why we are using the epsilon 0. So the permittivity of the free space. A is area of the plate. So this D is the separation distance. For example, plates of an empty parallel plate, capacitor of the capacitance 5 picofarad are 2 mm apart. So what's area of each plate? Using the capacitance equation, so we can write area is equals to CD divided by epsilon 0, and C is the capacitance 5 picofarad, and D is the separation distance 2 mm. When we use the SI units, we'll get the following calculation, and area is approximately 1.13 times 10 to minus 3 meters square. For capacitors connected in a series combination, reciprocal of equivalent capacitance is sum of the reciprocals of individual capacitances. For capacitors connected in parallel combination, equivalent or net capacitance is sum of all individual capacitance in the network. Second example, C1 3 picofarad and C2 2 picofarad. Calculate equivalent capacitance of network shown in figure between points A and B. So first of all, to simplify circuit, I'll replace net capacitance of the series connection C1, C2 and C1 by C2 prime. So taking account the series combination of capacitors, C2 prime can be found by this equation, and C2 is 0.6 picofarad. Net capacitance Cp of the parallel connection C2 and C2 prime is 2.6 picofarad. C1, Cp and C1 are connected in parallel, so equivalent capacitance between points A and B will be 0.95 picofarad. Third example, a capacitor is formed two square plates, each of dimensions A, separation D, connected to battery. There is a dielectric medium of the permittivity between the plates. The dielectric medium is pulled out at speed V. Calculate the current in the circuit as the battery is recharged. So the electric current is the time derivative of the charge. Charge of the capacitor is C times V. So I will compute the net capacitance by dividing two capacitors which are connected in parallel. Capacitance depends on area, separation distance of plates, also medium of the filler. So I can replace C1 and C2 by these expressions, where epsilon, dielectric constant, epsilon 0 is the permittivity of the free space, and the product of A and X is area. And after simplification, we will have the charge as a function of x. So derivative of charge is current. So the first fraction is constant. That's why it got to 0. And we will have this equation. Time derivative of x is velocity. Current is minus epsilon minus 1, epsilon 0, a, v, and the speed divided by d.